Online formative assessment. A wave of amplitude 0.3 meter interferes with a second wave of amplitude 0.2 meters. What is the largest resultant displacement that may occur? The largest resultant displacement occurs when two crests meet at the same position. So the displacement is uh, the sum of the two amplitudes, or if two crests meet at the same position. So here 0.3 meter plus 0.2 is 0.5 meters. Now a string is rigidly attached to a post at one end. This means that it is attached to a fixed end. Several pulses of amplitude 0.15 meters sent down the string are reflected at the post and travel back down the string without a loss of amplitude. What is the amplitude at a point on the string where the maximum displacement points of two pulses cross? And what type of interference is this? This case is a case of reflection by a fixed boundary. The reflected wave with the same wavelength inverts its orientation of displacement. It's impossible for a crest of an incident pulse to meet with a trough of a reflected pulse. That's why in this case, if the two waves meet at maximum positions, it means that a crest meets with a trough and thus destructive interference takes place. So the resultant amplitude is the difference in amplitude. 0.15 meter minus 0.15 meter equals 0 meter, and the interference is destructive interference. How would your answer to item 2 or to question 2 change if the same pulses were sent down a string whose end is free? And what type of interference is this? This case is a case of reflection by free boundary. The reflected wave with the same wavelength does not invert its orientation of displacement. It's possible now for a crest of an incident pulse to meet with a crest of a reflected pulse, or a trough of an incident pulse to meet with a trough of a reflected wave or pulse. That's why in this case, if the two waves meet at maximum positions, it means that a crest meets with a crest or a trough meets with a trough, and thus constructive interference takes place. The resultant amplitude is the sum of the two amplitudes, 0.15 meter plus 0.15 meter, which is 3 meter. This is constructive interference. A stretched string fixed at both ends is 2 meters long. What are three wavelengths that will produce standing waves on this string? Name at least one wavelength that would not produce a standing wave pattern and explain your answer. N lambda over 2 is L. This is the condition. So lambda is 2L over N, where N is a positive integer, يعني a natural number. N may be 1, 2, 3, 4, and so on. For the first order, we call it here the fundamental frequency, or the fundamental harmonic oscillation, or the first order harmonic oscillation, where n equal 1, يعني only one loop forms on the string. So for n equal 1, substituting in the condition here, we get lambda over 2 equal L. Then lambda is equal to 2L, and L is 2 meters, so 2 times 2 is 4 meters. If n equal 2, we have 2 over 2 lambda equal L, so lambda equal L, lambda equals 2 meter. N equal 3, 3 lambda over 2 equals 2, so we do the calculation and find lambda to be 1.3 meters. Now the other part is concerning naming at least one wavelength that would not produce a standing wave pattern and explain your answer. So any value other than these calculated ones, any value in between them, is a wavelength that would not allow a standing wave to take place. So the lambda will be, for example, 2.5 meter.